Many classes consist of a collection of other objects. In this example, we will use a card class that has one piece of data representing a playing card, along with methods for getting useful information about the card. We also have a card deck class that contains a collection of cards, along with methods for shuffling the cards, creating a fresh deck, and dealing a card. While most classes combine multiple pieces of data, the card class has only one value indicating which card it is. It is still appropriate to use a class, so the person using the class does not need to worry about how to compute the face or suit names for the card, or the information the other methods compute. We will also step through a main function using the classes, showing how they work, and what happens if you make some mistakes that beginners often make. Here we have a card class whose constructor takes one integer from 0 to 51, representing one of the cards in a card deck. Since that is the one piece of data we need for the card, we store it as an instance variable named card number. As a reminder, the data type of self is always the type of the class, so in this class self is always a card object with one piece of data indicating the card number. We have a method for returning the name of the suit, a method for getting the name of the face, a method for getting the blackjack value, a method for getting the file name for the card image, and the _str method. Note how some of the methods use additional local variables, which are not prefixed with self, but the only instance variable we need is the card number. The _str method calls other methods to help it get the information for the card. You must prefix those calls with self, as methods must always be called with an instance of the class. In most cases, when calling a method from within another method, you want to call that method with the same object with which this method was called. Now let's look at the card deck class. We import the card class from the card.py file, so we can use it in this file. Normally the constructor initializes all the instance variables, but in this case, we may later want to put the deck back in order, so we have a helper method named freshDeck to do that. Instead of duplicating the code both places, we call the freshDeck method from the constructor. PyCharm warns us that we may not want to initialize instance variables outside the constructor, but in this case that is okay. By the end of the execution of the constructor, we have all the instance variables initialized, and those are the only instance variables we will use in the other methods. As we discussed with the card class, you must always call a method with a specific instance of the class. We use self here to call the freshDeck method, so we are calling it with the same instance that the constructor is initializing. Our card deck is represented by a list of 52 cards, and a position indicating the index of the next card in the list to deal when the deal1 method is called. The other option to avoid keeping track of the position would be to mutate the list and remove the cards from the list as they are dealt. Note that each item in the list will be an instance of the card class as we call the card class constructor and insert its result in the list. When the freshDeck method completes, we have a list of 52 cards and the position variable set to 0. The shuffle method mutates the list by reordering the cards in the list using the random module's shuffle function. The deal1 method makes certain we haven't run out of cards. If we haven't, it gets the next card in the list. It also updates position, so the next time we call deal1, it will be set to get the next card. Finally, it returns the card. If there are no cards left to deal, the deal1 method returns the special value none. Another option we could have used is to raise an exception if the deal1 method is called when there are no cards left. We'll step through the program to see how it works. I purposely made a few mistakes to help you figure them out when you make these mistakes. We'll step into the card deck constructor and then step into the freshDeck method. We'll step over a few statements and see the loop begins inserting cards into the list. PyCharm uses the cards _str method to show us the value of each item in the list. We can also expand the card to see its instance variable card number. We'll step out of the freshDeck method, and we can see that the full list of 52 cards was created. We'll complete the constructor and step over the code that creates a second card deck object. Note that these are separate card deck objects, and each has their own list of 52 cards and position value. We'll step over the shuffle method, and now we can see the cards are in a different order. We wrote a _str method for the card class, but not for the card deck class. If you print an object that does not implement that method, Python outputs the name of the type and the memory address for it. So while this is not a mistake, if you want to print a string representation of an object, you need to implement the _str method for that class. A common semantic mistake is forgetting the parentheses when calling a function or method. This is legal in Python as it causes the card variable to hold a reference to the function, but in most cases you want to call the method. When we print this out, we see that it is a method for the cardDeck class. If you see something like this, it likely means you forgot parentheses when calling a function or method. Next, we'll step into a call to the deal1 method using the deck instance of the cardDeck class. Since that deck is shuffled, the cards are in a random order. We'll step over the lines to get a card and increment the position so the next time we call the deal1 method with the deck object, it will deal the card at position 1. When the method completes, we see the card variable is assigned an instance of the card class. When we print it, it calls the card class's _str method with the data for that card and outputs the name for it. We'll step over the next call to deal1 and see we get the next card from the list and the position is now 2 for that card deck. Next we'll step into the call to deal1 with deck 2. We did not shuffle this deck, so we can see the cards are still in order. It returns the card that is the ace of clubs and increments the position to 1. We'll now step over the call to fresh deck using the deck card deck instance. It puts the cards back in order and sets position back to 0. We'll step over the call to shuffle, and now the cards are in a random order, but position is still 0. Since we know there are 52 cards, we should use a for loop to deal and print all the cards, but I want to demonstrate one other concept, so we'll use a while loop. When there are no longer any cards left to deal, the deal1 method returns none, so we can check the return value of it and stop the loop. Normally we use the double equals to test for equality, and the exclamation point equals to test if items are not equal. But when testing if a value is none, we can use the Python is keyword. Comparing none using the is keyword is more efficient, and works because there is only one copy of the none value. The is keyword checks if two objects are the same. This can be useful if you want to know if two different names refer to the same object. In most cases you want to know if two variables hold the same data, even if they are not the same object. We generally use the double equals and exclamation point equals for those equality tests. Since we just called the fresh deck and shuffle method, there are 52 cards left to deal, and they will be in a random order. We deal the first card before the loop to prime the loop. This card will not be none, so we print it, which calls the _str method for the card class, since that is the type of the card variable. We then get the next card and check the loop condition again. We'll resume, and you see that it printed the string representation of all the cards. I used a conditional breakpoint on the while loop, so it stopped when card is none. After dealing all 52 cards, the deal1 method returns none. We can step over and see it completes the main function. After stepping over one more time, the program completes.